Hello. Well, that's a mouthful. Leveraging CAG or CAG, RAG, and MCPs. So in this room, I bet that some of you have heard of these terms. We're going to go a little bit through them. But if you haven't, probably you're thinking of either adopting or building an AI system, at least considering. So it is easy to think about a system like a chatbot or an automation, and even in some cases envision a post-apocalyptic world like Terminator, like where is AI taking us? But really, what is hard to imagine is what lies beyond, like below all of that. What is the context? And I'm going to be talking about what's beyond. So who am I? Why am I talking about this? So I work in technology for a long time. I've been part of like over 60 projects on more than 20 countries, worked with multiple corporate brands, and I also work in some personal projects and ventures, and support startups as a consultant. So, how does enterprise AI look like? When we think about AI, as I was saying, we start to think about chatbots, agents, dashboard, or RAGs, retrieval augmentation. But below those services, like an MCP or a RAG, or even connecting APIs to an agent, we need to think about data sources. And this is when we start to get technical. Real-time feeds, knowledge bases, prompts. And when we go deeper, some things that we need to consider is what is the perspective of stakeholders when they implement these systems, or when they buy the systems, or when they are trying to solve a problem. So for example, standard operational procedures, monitoring, financial operation of your AI systems. And finally, what is the ultimate goal of that system? Is it money, return of investment? Do we need to have compliance? Or what about adoption? How is this going to impact humans? So to go over these concepts, we need to first understand what are like these RAG or CAG. A RAG, for those who are not familiar with the term, is retrieval augmented generation, and basically is to let a large language model access information on demand. Then we have CAG or CAGs, which oddly enough, we have two acronyms for that. We have context-aware generation, which is reading through the context through an interaction. So basically history. And we also have cache-augmented generation, which is introducing preloaded context that allowed us, especially in enterprise, to reduce cost or increase the speed of the systems. And finally, the relatively newest tool, MCPs, which is multi-context protocol, which is a protocol created by Anthropic that allowed us to orchestrate these systems and let LLMs communicate back and forth so we can use these tools together. So, moving on, when we think of these systems at scale, like we're not talking about a simple chatbot, but something that will have millions or billions of requests, we need to balance some trade-off. To make decisions on what systems to use, we need to consider the predictability of the system, so how easy it is to architect, or the complexity. How many data sources? Is it real time? Will we have internet? Is this in the edge? And in the other hand, we need to think about, are we automating? Are we doing a predictable process? Or are we doing this to make people more productive? So are we replacing someone's job? Or are we making it better? And if we follow that axis, we can figure out that there are some general guidelines of what type of architectures you should be encountering If it's a complex system that requires augmentation, you will need a full hybrid architecture, which is like most common systems in the enterprise. Or if you have a complex system that is solely for automation, you can just do well with retrieval augmented generation and MCPs. So the rest is just basically your simple LLMs. We're gonna not talk too much about them. We're talking about enterprise. So, automation versus augmentation. Are anyone in this room familiar, who is familiar with the term human augmentation? Any hands? Okay, so not many hands, maybe shy crowd, but augmentation is to help people's work be better. So, for example, everyone uses LLMs for like drafting emails or things like that, even orchestrating your calendar. So that is a basic human augmentation. Automation, on the other hand, well, most people will be familiar with this, is just replacing a manual process with a systematic approach. When we compare these two, we do automation to reduce human intervention as much as we can. And basically, we put a set of rules and define an input and an output and a process in between, but it's fully predictable. Augmentation, we use it to enhance human decision capabilities or provide intelligent insights. Like one of the most common implementation for augmentation in enterprise is to use predictable AI. Like we think of AI as a search engine, but actually is a predictive algorithm. So if we move into how do we use this, I'm going to go through a simple architecture of a hybrid system. I picked this case because these diagrams can get very, very large. And this one is something that probably most people is familiar. It's simply creating an issue. So what if we want to create an issue, but we want to go through all the context? Think about a large organization where a lot of meeting goes just to change the color of a button. So in this system, we will see how an MCP will orchestrate different parts to access data sources, inject context, and accelerate cache so that this request is almost real time. This is a real case. So I'm going to go through it. So we can use a normal UI to make the request. So we say, hey chat, I want to create this issue, and we put some simple prompt. Let's think about a normal engineer, let's think of a junior just going through and say, change the color of the button. No context, no criteria of acceptance, nothing, just that. So the MCP will take this request and run it through a pipeline. So this pipeline, this is not a synchronous, but I'm going to go one by one. All of them will happen at the same time. So first, it's going to go through retrieval. So retrieval is the more common of all. In this case, the MCP needs to check the knowledge base. So how do we create issues? What are our prompts? What are our templates? So it injects it in the context. Then it will go through object storage. If we have any diagrams, any file. It also would take any meeting transcripts. And this one was very important for the case because a lot of the things were scoped in discussion, but were not really documented. So there is another agent that captures everything and transcripts. And finally, it goes through comments and discussion. So it reads Git, it reads linear, it reads lags. And finally, if this touches any additional system, it will go through integrations that will touch the relevant data. So then we have the context. So normally, this doesn't happen in a single interaction. Like, When you do that broad prompt, probably the MCP is going to reply to you with thanks to another part of the process that will go at the end. But if the prompt doesn't go through validation, it will interview you. It will ask you questions to clarify the context to avoid hallucinations. So every request that you do, it will go through your chat history, and it will go through your prompt, and it will also touch your project and system prompts that were created by either by you or by another user. And finally, we have our cache agent, which basically, in this case, we use it for policy, quality control, and noise reduction. So I'm going to stop a little bit with this part. Policy, because in some cases, most cases in enterprise, you will need to have some sort of compliance, like GDPR, HIPAA, SOC, or some ISOs. So sorry for the acronyms, but all of these are like standards for security or data privacy. So this agent will go through those and assure that when anything is scoped that touches any of these standards, it will have them in consideration. So engineers won't go and code something that won't go through QA. And the noise reduction is also very important because there is this term, this happens when someone starts to read an issue and the issue is too large, or it sounds like it's written by a machine. Pretty sure that some of you have received like emails that are clearly not written by the person. So the noise reduction agent will just take the personality of whoever is reading, the writing style and everything, and just try to put some makeup on whatever the output is and ensure that it's more human readable. So in this case, all of this goes through the LLM processing, and it will draft an output. So this draft will go to your cache agent, and will do, in this case, output validation. And finally, it will do quality assurance, and it will generate the clean output. So the clean output would be our issue, but now we will have a properly structured issue between companies' compliance that is readable by people. So then we introduce the human in the loop. So all of this still a draft. In this particular case, none of this goes to your backlog. So what happens here is that it goes to a triage, and the person in charge, which probably is a project manager, but also the person that requested creating the issue, will have to read it and manually approve the issue so that we know that there are no scoping that is out of the requirements. So in general, this is a process of how just an issue is created. You can imagine how this can extrapolate to other more complex processes. In my case, I have to do like some hybrid systems for video processing in real time, which require a lot of care, especially with FinOps. And you need to make all of these microprocesses. You know, many people here is more on the software side and will not be keen on like microservice, but agent distribution is very important, because if you have like autonomous agents that do all, then you will end up with systems that either cost too much or that hallucinate very quickly. So when you're thinking about architecting an enterprise system, there is many considerations, but here's a very short checklist of how we should think about it. There is a technical side to everything, and then there is a strategic side. So on the technical side, we need to think not only about the issue itself or like the problem that we're solving, but also the operations, like observability, financial operation and cost optimization, the infrastructure management, and incident response. So we need to ensure that we can react to whatever happens in the system. Then security and compliance. AI is very delicate, especially in industries like health tech or FinOps, where you need to have like proper data governance and access patterns that allow you to be in compliance, especially with HIPAA, SOX, or GDPR. But on the strategic side, so those decision makers that are not that technical, that they care more about getting the new AI shiny toy and cut some cost or generate some revenue rather than the actual system itself. So for them, you need to have clear success metrics and KPIs. You need to align your system to standard operating procedures. And well, the rest, not gonna go like to everything, but there's a lot of like benchmark and things that you need to do to justify the investment of this type of system. But the most difficult one, and probably the more ignored, is the digital transformation part. So this is true for every technical system. Like you introduce to a company a new application, a new tool. We're stopped using Jira, now we use linear kind of thing. But for non-technical people, the adoption is really, really hard. So people will be resistant to change. And when we talk about AI, they are even more so because there is this like belief that arguably part of it is true, that artificial intelligence is going to replace humans. So this is the polemic part of the talk, and this is where this is going to be my opinion. I believe that this is more about augmentation and enhancing human capabilities and also letting humans focus more on critical thinking and creative tasks rather than tedious tasks like writing a report. You can automate those things. You can get help from AI for those things. But then an AI cannot be as creative as you can. You can use it to have ideas and also to support. But at this stage of the game, we are not able to let it do everything. So there are some common pitfalls, though, to designing enterprise systems. And to any system architecture or software engineer or AI engineer working, like present in this room, these are like the 3 top categories of pitfalls. So the first one is bad processes. If you don't know what's going on, if you don't know what you're trying to achieve or how the process works in the actual company, then you're not going to have a good input-output, and also the adoption is going to be more difficult. This is particularly important when designing systems to do waste reduction or cost optimization. You need to understand the process, and in some cases you will find processes that are so outdated that you need to revise the process from a more managerial perspective rather than technical. The second one, a lot of you will be familiar with this, is garbage in, garbage out. If the data and the prompts that you are adding to the system are not good, the result is not going to be good. So it doesn't matter how good the system is, you need to have good data. And this comes at a cost, because sometimes we believe good data just adding more data. Even if it's accurate, just adding and adding more context. What's going to make is the system less cost efficient, and sometimes it will also make the system hallucinate because it has more context than what it actually needs for a specific request. So in these type of scenarios, make sure that you have good data in and that you make tests to make sure that the system has the right amount of data and the right amount of context. For this, you can do prompt engineer, and you can do in your architecture some small agents that can make some decisions to point to the right data, or you can do it automated, like just with regular automation, if possible. So opt not to use AI in this type of systems whenever possible to minimize the hallucination rate. The final one is bad design. And in this case, the number one that I've seen is trying to have an autonomous agent to try to do everything. So this is specifically interesting when you talk to decision makers, especially in the area of customer support or sales, where they think that, okay, let's just do an autonomous chatbot and not putting any process. Because then, well, we have this hilarious story of like making one chatbot, and it was to generate leads. So it actually worked. It increased dramatically the amount of generated leads, but then the sales force didn't have enough bandwidth to process the sales. So they end up losing customers rather than gaining customers. So that's bad process design. The other problem that we can find is not having specialized components. So try to break down, if you're building a rack, try to separate the pieces and incorporate small agents. I always tell people, like, think about a department where you have different specialty people, or maybe a soccer team, a football team. Like, you have every agent in the right position being particularly focused on solving a specific problem, and then connect them and put them to work together. And with MCP, things are easier because you can inject data in real time to them. And then finally is the over-reliance on large language models. Certainly now adoption on automations is better for software engineers because people have the belief, non-technical people have the belief that now is the time to do AI to improve processes. But there are some processes that could be automated without the need of AI. And there was more resistance because there's like the most common excuse is, well, we have been in this industry for 20 years, 30 years. And to do this process, we need someone experienced. This cannot be automated. This is a very common thing. But now the decision changed because they believe that introducing AI, they have someone thinking through the process. So it's a good opportunity as well for software engineers to propose automations where AI is not needed, or AI can be introduced in part of the process, but it's not the whole process about AI. And well, basically that's it, like ignoring automation. So from all of this, what are the key takeaways? The number one is we need, when we think about effective enterprise AI, we need to balance complexity with business value. So when you are designing a system, you need to know what is the purpose of the system and what does it take. And just try to balance, because sometimes we are trying to make the system as perfect as possible as software engineers or AI engineers, but we are disregarding what is the ultimate goal. On the other hand, you have stakeholders that just want to get to the goal. More money, less expenses. Like these type of goals are the most common, but then they disregard what is the infrastructure, what is the operation, and how does it take to run this system. So we need to balance those. Combine automation and augmentation. So this is very crucial. Like, we need to have a good understanding on when to automate and when to augment. And sometimes doing automation leads to augmentation, because if we can use automation, even with AI, to replace certain processes, let's say write my weekly report or my daily report. If I can do that automatically, then I can focus on other tasks like building, creating, thinking, solving problems. So we need to combine those. And finally, at scale for enterprise, you need to use hybrid architectures. Combining MCP, like just putting an MCP and trying to combine rack system with context augmented and cache in the system will be better to get the systems to work at scale, because we will ensure that we have like good data in, good data out, better processing, faster results, and much better operation. So I appreciate the opportunity. Thank you. And if you have any question, now's the time.